Here is a problem of determining ABCD parameters for a given two-port network. The problem is as being seen. We need to determine the ABCD parameters for this given network, and we are also expected to verify reciprocity, the principle of reciprocity for this network. We are supposed to find out whether this network is reciprocal or not. Let us go ahead with this particular problem. So to begin with, we need to determine ABCD parameters. Let us try to recollect the equations relating ABCD parameters. Alright. So we have the equations to be, I'll write down the equation. V1 equal to AV2 minus BI2 is one equation. The other equation is I1 equal to CV2 minus DI2. We know these things, right? So these are the two equations which relate V1I1 to V2I2 through ABCD. Here V2I2 are independent variables and V1I1 are dependent variables. So V1I1 expressed as a function of V2I2. Okay, so ABCD parameters or transmission parameters are related to V1, I1, V2, I2 in this manner. Okay, so in order to determine these parameters, we need to either short circuit the output port or open circuit the output port. What do we understand by short circuiting output port? Short circuiting output port would render V2 voltage to be 0, and open circuiting output port would mean I2 equal to 0. So in either case, when V2 is 0, if we call this equation 1 and equation 2, if V2 equal to 0, in equation 1, the V2 term will go away. I will take this ink. Suppose this will go away with V2 equal to 0. Here this will go away. So I will be able to determine B and D. Okay. On the contrary, if we make I2 equal to 0, means when I2 is 0, BI2 would be 0 and DI2 would be 0. That in that case, we would be able to determine A and C. Alright. So that is the idea. So in order to determine these four quantities, we need to either open circuit the output port or short circuit the output port. So we know what to do, right? So we'll first write the steps involved. The first step, step 1, we will try to make I2 equal to 0. Means we will open circuit the secondary port. So you know what we mean by secondary port. Secondary port quantities are V2, I2. Those are the positive directions of measurement. This is positive, this is negative, this is positive, this is negative for V2, and correspondingly I1 and I2 positive directions are being indicated in the diagram. Let us try to open circuit the secondary port. What does that supposed to mean? When secondary port is open circuited, there is no current that flows out of the port, or in other words, I2 is 0. Okay, so there is no current in the open circuit. This fundamentals we know. Now what I'll do is I'll try to reproduce this diagram. I'll rewrite this diagram for convenience. So I'll copy this diagram. I'll copy. Maybe I'll paste it here. Position it properly. Okay, so the circuit itself now, if we see this particular circuit, here I2 is 0. So there is no current. There is no current here. The current is not there in this path, right? So I2 is 0. Okay, so how do you determine the various quantities? So in order to do it, let us try to represent few variables. Okay, so let us try to denote this voltage as, let us say, V3. This obviously is at V2 voltage, and I'm assuming this to be at ground potential. Okay, the various variables are being indicated. I will take this current as I3. The current in this branch, I will take it as I4. the same current would flow here, I4, because the current cannot take this path. There is nothing connected here. So this I2 is 0. Alright, so I can put this I2 to be equal to 0. This current is 0. So these things are absolutely clear, I suppose. Now we will try to express each quantity in terms of the other. How do we go about? We start from the output port. We try to alternatively go in for current and voltage expressions. Now to determine the ratio of V1 to V2, which will give me A, and I1 to V2 will give me C, right? So I need to compute these quantities. Like I need to have an expression for V1, V2, that will give me A. And if I can have an expression for I1 and V2, an equation for I1 and V2, I'll be able to get C. So what is it we have done? Let me try to write from equation 1. From 1, I will use my white color back. This is for our understanding, for our ready reference. From 1, okay, A can be determined as V1 to V2 because we have made I2 0. Alright. Similarly, C can be determined as I1 to V2 with I2 0. So with I2 0, we will be able to determine A and C. Okay. So now let us try to remember these two expressions, then go ahead. What is my I4? If I need to write an expression for I4, I can write I4 as current is voltage upon resistance. What is the voltage across this particular branch of 2 ohm? It is V2, that is the voltage, V2 divided by the resistance of 2 ohms. Okay, this is the expression for I4. Now, what is this? Now, I'll alternatively go for the next previous voltage. I will write an expression for V3. What is V3 equal to? If I want to determine the potential at this node, which is V3, it is V2 plus the drop here in 2 ohms, right? I will write. So, V3 equal to V2 plus 2 into I4. Alright, 2 into I4. So, what do? I will substitute for I4 from the previous expression. So, this can be written as V2 plus 2 into, I have recently obtained an expression for I4 to be V2 by 2. Okay, so I will cancel off this 2 and 2. I'll use a color. 2 and 2 I will remove. Now, what I'll get is, this is V2 plus V2, 2V2. Okay, so V3, I'm able to get it as 2V2, right? So, I will write it separately. V3, we may use this expression. V3 equal to 2V2. Okay, now what is the current I3 equal to? Because we need to arrive at I1, right? So, we wrote an expression for I4. We wrote an expression for V3. Now, from V3, I will write what is I3, the expression for current next. Okay, so I3, the current through 1 ohm is the voltage across 1 ohm, which is V3 minus 0, that is V3, divided by 1. Okay, so the current I3, let me repeat it. The current I3 equal to V3 minus 0, potential difference across 1, divided by 1. So, V3 by 1. So, what is V3? From the previous expression, I can substitute for V3 as 2V2 by 1. Alright, now I will get back to the current I1. Okay, what is the current I1 now? If I need to write the current I1, so I1 equal to the current I3 plus the current I4. Applying KCL, the current here is equal to the current here, that is I3, and the current here. KCL at V3. KCL at this node. Okay, so that is I1 equal to I3 plus I4. Alright, so what is I3? From the previous expression, I will substitute for I3 as 2V2, and for I4, I will substitute V2 by 2. Okay, this is 2 plus half, 2 and a half. This is 2.5 V2. What is that? The resulting expression, we can write it as I1 equal to 2.5 V2. Okay, so we are able to write an equation relating I1 and V2. That is what is our C. From this expression, if you can see, this is, let us say, this is my equation 3, this is my 4. Okay, from 4, what can we say? From this, if I can write as I1 upon V2 is 2.5. So from equation 4, this is equal to C. Okay, therefore, C equal to, which is I1, I am repeating it, I1 to V2 with I2 equal to 0, and that is equal to 2.5. So, we able to determine one quantity C, the unit of C, if we can see, current to voltage, that is mhos. So, I'll try to enclose it in a box. Okay. So, we are able to determine the value of C. Now, what is V1 from the diagram? Now, we will have to determine A, right? A is V1 to V2. So, we need to have an expression for V1. So, what is V1? The voltage here, V1, is V3 plus the drop across 1 ohm. Okay? So, that we will write. So, from the network, V1 is given by V3 plus the drop across 1 ohm, that is 1 into current through 1 ohm, that is I1 amperes. Now we will substitute for V3. What is V3? I'll take this value. V3 is 2V2, and for I1 I will substitute 2.5 V2. That is from C. Okay, for V3 I will write 2V2. You can see that equation. Here you can keep numbering, then substituting. That can also be done. Plus this is 2.5 V2. Okay, that can be added. 2.5 plus 2 is 4.5. 4.5 V2. What is that? V1 equal to, so we have V1 equal to 4.5 V2. Okay, that is what is A. Now, if I can take the ratio of V1 to V2, I'll get this as 4.5. And from 3, what is it we get? From 3, we can simply say A equal to V1 to V2 with I2 equal to 0. This being a voltage ratio is unitless, right? That's 4.5. Alright, so this is another result we have. So we are able to determine two quantities, that is A and C. That is A and C by open circuiting the secondary port. Okay, this is the first step. In first step, we open circuited the secondary port, determined A and C. Now, what do you have to do? To determine B and D, we need to short circuit the secondary port. These are all simple problems. All you require is the knowledge of KCL and KVL and nothing else. Okay, so let us try to go ahead with the further aspect of the problem. Step 2. What do we do is, we will short circuit port 2. What do we mean by short circuiting the port 2? We mean V2 equal to 0. I'll rewrite the diagram. I'll reproduce the diagram again. I'll take this diagram. I'll copy and paste it here. Okay. So what do I need to do? I will have to create a short circuit. I will short this port. Okay. When I short the port, what will happen to the potential difference between the pair of terminals 2 and 2 dash? What I have done is, this is my 2, terminal 2 dash, terminal 1 dash. Between 2 and 2 dash, the voltage is being made 0. Okay. So now how do we understand this network? So if you can see, across 2 and 2 dash, we have placed a short circuit. Across which we have a 2 ohm resistor. So if we place a short across any resistor, there is no current through this. So it is as good as this being not there. Rather, we can afford to open circuit this branch and look at the network. Let me rewrite the network now with that reduction. What I mean is, this is same as, or else what I'll do is I will copy this diagram, reduce in size, put it here. This I will copy. I'll paste this adjacent to this. Now what I'll do is, I'll remove this branch. It is the same network. Maybe I'll reduce it in size. I'm just reducing the tag. That's all I'm doing. Just a second, I will reduce this and shift it here. Okay, now this and this are same. This is same as this network. Okay. Now look at this network. Now this is how the circuit would behave. I1 is the current which would come up to this point, From there, the current would flow through 2 ohm in this direction and come back this way. So the conventional current I2, the positive current is in this direction, but actual current is going to flow in this direction. I'll call this I2 dash. All right. I suppose that is clear. Okay. So we have I2 to be equal to minus I2 dash. Okay, the actual current is flowing in the direction opposite to that of the conventional current. Now, how do we understand this network? So when we look at this network, this 2 and 1, they are in parallel. That will be in series with this 1 ohm, and total resistance offered by this network is 2 parallel 1 in series with 1. That is going to be the overall resistance offered to the flow of current I1 from the source V1. That's how we understand, right? So it's a simple series parallel network. So in other words, I can simply write the current I1 equal to voltage V1 divided by 1 plus the parallel combination of 2 and 1. 2 parallel 1. In other words, this is V1 divided by 1 plus, how do we do the parallel resultant? It's 2 into 1 divided by 2 plus 1. So if we simplify this, I'll get it as 3V1 divided by 5. Okay, 3V1 divided by 5. And what is now I2 equal to? Now I2 equal to, we will have to apply the current division. Current I2 equal to minus of the current division. How do we apply the current division? Total current I1 multiplied with the resistance of 1 ohm divided by the sum of the two. That is 3. 2 plus 1. Okay, this is equal to, I will substitute, minus 3V1 divided by 5, that is I1, and this multiplied with 1 by 3. Okay, I have substituted for I1. For I1, I have substituted 3V1 by 5. Okay, so now my 3 and 3 would get cancelled. 3 and 3 gets cancelled. Now I am left with minus V1 by 5. What is that? That is I2 equal to, or in other words, or V1 divided by I2 equal to minus 5. Okay, so from equation 2, we will go back here. From equation 1, if we look at equation 1, we can write what is B equal to. Okay, from equation 1, should I reproduce these two equations? Maybe I will. I will take this, I'll copy, I'll paste it here. This is for our reference. Okay, so now from equation 1, if we see from equation 1, this is what is minus B, minus V1 to I2 with V2 equal to 0 is what is minus B, and that is equal to minus 5. Okay, therefore B equal to 5. Therefore B equal to 5. This is a simple thing, and this, the unit of this is ohms. Alright, so we are able to determine one more quantity. Now we are left with another last quantity, that is D. Okay, so D, we have to determine the ratio of I1 to I2. Okay, so we have an expression for I1 already, but we need to know what is I2 equal to, then we will be able to get that. Okay, so we have got I2 equal to, I1 equal to I2. So we have an equation relating the two quantities, D equal to, minus D equal to I1 to I2. I1 we have substituted, we can substitute 3 V1 by 5, and for V2 also we can substitute, then we will get I1 to I2 ratio. Let's go ahead. Minus D equal to, I'll take my white pencil back. What do we have minus D to be equal to? Minus D, from equation 2, minus D can be written as I1 to I2, and this is with V2 equal to 0. Okay, so the results that we have here. What is I1 equal to? So from this equation, we will take I1 to be equal to 3 V1 divided by 5. And what is I2 equal to? So we will make use of this expression for B. We'll make use of this. What is I2 equal to? V1 by 5. This is minus 5 this is I2 division, right? So this is I1 divided by, what is I2 equal to? I2 is minus V1 by 5. This can be written as 3V1 by 5 into 5 by V1, whole thing with a negative sign. Alright, so my V1 and V1 would get cancelled. 5 and 5 would get cancelled. And minus D equal to minus 3. Or D equal to 3. And this being the ratio of two currents, it is unitless. So we are able to determine all the four parameters. These are ABCD parameters. Alright, let us collect them together. What is it we have got? We will try to collect what is A equal to, because we need to verify the principle of reciprocity, condition of reciprocity. So A is 4.5, B is 5, C is 2.5, and D is 3. Okay, so what is the condition for reciprocity? There is a proof. We can always carry out the proof and obtain this condition. I'm not covering the proof of this condition, but however, I presume that the viewers know. Condition for reciprocity is, in terms of ABCD parameters, it is AD minus BC, which should be equal to 1. If this is true, then we say that the network is reciprocal. Okay, let us go ahead with the left-hand side. Left-hand side of this equation is AD minus BC. A is 4.5 for this network, B is 3, minus B is 5, C is 2.5. This is 4.5 into 3 is 13.5, minus 5 into 2.5 is 12.5, which is equal to 1. And this is our RHS. So as AD minus BC is 1, as AD minus BC for this network is unity 1, the given network is reciprocal. Hence, the problem is done. Okay. So I suppose it's a very, very simple problem, a simple network having only 4 resistors, and we need to determine ABCD parameters, and we have gone ahead with this. Hope this is clear.